Hello, everyone. Welcome to today's Qualitrol webinar, moving from time-based maintenance to condition-based maintenance. It's being presented by Thomas Lynn. My name is Brian Azinski, and a few housekeeping items before we begin. Everyone is on mute so that we have a nice, clean audio feed from Thomas. You will have the ability to do a question and answer session at the end of the presentation. It'll be via the chat window, so you can type in questions into that chat window at the end, and I'll be reading them out loud, and then Thomas will be answering them. This webinar is also being recorded, so for those of you who want to see this after the live version, you'll be getting an email with a link in it that'll have the recorded version, so you can watch it at any time or re-watch it. And today's presenter, Thomas Lynn, 20-plus years experience in the high-voltage equipment such as gas-insulated switchgear, high-voltage bushings, cables, transformers, high-voltage testing, partial discharge management and monitoring, and high-voltage test equipment. Needless to say, he has plenty of wonderful years of experience. We're very excited today to have him presenting today's webinar. Without further ado, here is Thomas.
Hello, everybody. Ladies and gentlemen, good morning, good evening, however the time is at your side. I'm glad that I have the possibility to talk you through moving from time-based maintenance to condition-based maintenance. And I want, first of all, go through maybe some dry stuff like definitions around maintenance. We want to look for traditional methods and current state of maintenance. Before we then going to the main interest of condition-based maintenance, what does it mean? What are the basics for these? What are the principles? And I guess still there are some challenges for condition monitoring and for condition-based maintenance also. And later on, as you heard, you may ask questions about the topic. Okay, first I want to start with the definitions around maintenance. So most of you may know what does it mean, maintenance. Basically, maintenance are actions necessary just to maintain your equipment and that in a health condition, and you want to reach the promised life of your equipment, of course. And well, that is a basic definition, but there are different types of maintenance known. So maybe for all very present is the kind of reactive maintenance. We call it also run to failure maintenance. That necessarily means that you're just using your equipment until it fails. And next one would be preventive maintenance, also called time-based maintenance. That is actually when somebody is telling you you have to change your oil in your car maybe every half a year. And finally, we're talking about predictive maintenance, also called condition-based maintenance. So that means you're driving with your car to the garage when you need to change the oil, but you have to know how is the situation of your oil. And now we are just looking a little bit deeper about the advantage, disadvantage of the different kind of maintenance. First of all would be run to failure maintenance. As I said, basically you wait until equipment fails. Of course, looking through the fleet of utilities, there may be different kind of maintenance principles are possible to exist in parallel. For maybe just cheap equipment, talking about the laptop, you may do less maintenance. So you wait until it fails and then you maybe get a new one. What are the advantages and disadvantages? Of course, if you don't have to do maintenance on your laptop, of course you don't have to pay. So you just buy a new one. Anyway, to do maintenance on a laptop would be more expensive than just to buy a new one. And also you don't need anybody to do the maintenance, so you need less stuff. But well, most of the time your computer or your equipment breaks down in a moment where you do not need it, and then you need the people very fast. You have maybe to work overtime over the weekend, and you may pay more than for the people over the weekend. And you have costs involved in the repair and replacement of the equipment, because the equipment broke down. Maybe you can repair, maybe not. And also, you have the possibility in terms of maybe transformer, maybe GIS, that you're also destroying your secondary equipment. So maybe more equipment is involved than just only your primary equipment, which fails. And that's to just keep people for that one doing that is very ineffective. So let's look for the next type of maintenance. Are we talking about time-based maintenance? So just every 3,000 miles or every 3 months, which comes first? You're just bringing your car to the garage. Surprisingly, if you would do that instead of just wait until it fails, you would save 12 to 18% of your costs in terms of or compared to reactive maintenance programs. And of course, there would be energy saving, and you need maybe to replace only a few parts, only the parts which you found that they are not good. But on the other hand, you will not be able to prevent all the catastrophic failures. It's quite labor intensive because you have to have the people to doing these time-based maintenance. And it's also, maintenance always open up something, so you might also risk to incorporate more failure because of unneeded maintenance. Now coming to condition-based maintenance. And condition-based maintenance mainly says you're looking for a condition of the equipment, and according to that condition, you're going to do maintenance. So you're knowing how your oil in your car is looking like, and you know I have to go and to change the oil. So what are the advantages? Again, just starting on the bottom, you will save about 8% to 12% of cost over time-based maintenance again. And of course, energy savings again, because you just do something if it is necessary to do something. And it's also if you do maintenance or if you get a fault, maybe you run into some danger because of some equipment is breaking down, exploding in terms of life and health. And that you would like to prevent. And if you just taking care about your equipment, actually, then condition-based maintenance will close that gap, which was still open after talking about time-based maintenance. There are also disadvantages. Of course, if you want to do condition-based maintenance, you need to have some equipment which is telling you the health of your equipment. So you need to invest at the beginning a bit more. And you need to invest also in training of staff, because you get some information and you have to deal with the information. I will come to that one later. And the other thing is just, most of the managements are not seeing the potential really of condition-based maintenance, because that is a very long view, because you start to gain money not at the beginning, but over the whole lifetime of your equipment. What are the traditional methods? Well, as I said, we are having still a high level of reactive maintenance. For some equipment, it makes sense. If you have cheap equipment, you run it to failure and then you just change it. Maybe you have even equipment in parallel where you can just switch over. So that doesn't matter, but if you're talking about a transformer for some million and you're not able to deliver energy, maybe that's not the right strategy. 30% today doing preventive maintenance, which is a bit better, and 12% doing predictive maintenance, and 2% doing something which is in between or a combination of it. But still, today, more than 55% maintenance is still reactive. But talking about high voltage equipment, talking about transformers, talking about GIS, most of them today will be maintained in a time-based maintenance. So that means your supplier of the equipment is telling you you have to do maybe breaker overhaul after, let's say, 3,000 operations or maybe 15 years, and you will follow. Well, of course. And well, also in the earlier years, you do not have the sensors installed even today on older equipment to do or just to simply move to maybe time condition-based maintenance. So you don't have the information about the health of your equipment. And well, and especially if you're talking about equipment like capacitor banks, like underground cables and so on. So you don't open the ground, you don't dig in the ground just to see the condition of your cable and to do maintenance. So you will leave it there until it fails. Coming to the cost calculation, that is also, well, it change or need to be a change, because in today's calculation, which you see on the left side, you are just having the cost for the preventive maintenance, and maybe you have the cost for breakdown and what you have to pay to just coming back to normal operation condition. So, and you see the black line shows you the most effective point, but you have only taken into account replacement parts cost, labor cost, primary cost of outages, storage costs. But if you're looking for, if you're going to look for the whole picture, then you have all these soft factors, but not only soft factors, but they are also very important. Talking about the morale of employee, safety aspects, reduced costs for parts and labor, secondary outage costs like penalties, brand damages, etc., and also inventory cost and indirect cost by reduction due to longer lifetime. So these costs are all on the left side not considered. If you consider these costs, then you have the overall picture, and then it looks a bit different. Then if you're taking care about the equipment, that you do not have a breakdown, that you can use your equipment longer, of course, then the optimal point is somewhere else, and is more talking about condition-based maintenance. And also, we just I mentioned that one in one of the earlier slides. But looking at this statistic, what does it mean? The red ones actually is a breakdown of equipment. We're talking about the number of failures, and on the y-axis and on the x-axis, you're talking about the service years, means the age of your equipment. So the red ones, equipment defects, more or less remaining over the whole lifetime the same. Then, of course, you have the yellow ones. There are others, whatever it is. So that remains also the same. But if you look for the green ones, and that's actually failure happen after doing maintenance. So, and that's for more or less all kind of equipment the same. If you can imagine, you have a maybe 40, 50-year-old transformer, and I don't know how many people you might have in a utility who are still knowing how that equipment is looking like inside. And sometimes you might have also screw you need to cut because you cannot lose it anymore. So these kind of things happen, of course, with the age of your equipment. So, by the way, I would try to do maintenance only if it is necessary. Otherwise, well, you're increasing the risk of equipment, which is clearly seen in a statistic. Well, and now let's talk about what we can do advanced or before something happens. So there we have different events, like electrical short circuit faults by lightning. That will happen in milliseconds. So talking about monitoring, no chance. So finally, therefore, we have the relay protection. Further on, sometimes you have abnormal operations. At least I know from Europe that it happened. So most probably on all over the world it will happen that you make maybe wrong handling, and there you might have seconds, also milliseconds or hours. But well, that is some kind of let's say education of the people. So you cannot do anything with the monitoring. That's not possible. But talking about stress and aging of maybe, let's say, paper insulation of transformer, let's say about solid insulation material, let's talk about GIS, let's talk about transformer, let's talk about cable. That takes place not in milliseconds, that will last days, months, years before you have a degradation that you're getting a serious problem. And especially these kind of defects, there we can implement online monitoring. That actually are these kind of situations we try to find. So you still have a fair time before you have a real fault. Okay, now coming to condition-based maintenance. What does it mean? Well, again, the definitions we had before, and condition-based maintenance could be continuous or periodic condition assessment by some data you're gathering from your equipment by some sensors. So, well, basically that means you need some data about your equipment. Some, I don't know, you can talk about maybe DJA, or you can talk about partial discharge. You can talk about temperatures, hotspot temperatures. So you need this data just to at least to know what is your equipment, what is your situation in your equipment. So you need to define these values in this data. It doesn't make sense to measure something which doesn't help you. And you need to collect the data, you need to store the data, and now it starts to be very important because you need to do a data analyzing and a data processing, and out of these you just should get out data which could help you to assessing the condition of the equipment. And according to that one, only according to that one, you're able to defining maintenance decision. And that is the how let's say a concept would look like, which you can implement, or the parts you need just to do condition-based maintenance. So first of all, and that is basic, you need the commitment of management, because we learned before the advantage of condition-based maintenance is not really seen so far and today by all of the management. And the second one is you need to have a concept. Anyway, if you do something, you need to have a maintenance concept. Most probably you have a maintenance concept, but talking about condition-based maintenance concepts, that goes a bit more far, because you don't have a time when you have to do things. You have to do the things when they have to be done. So that is a different concept. And to just have the information, to be able to get the information, you need suitable sensors, a reliable system, and you get out of some data. This data you have to process, and you have to analyze the data as mentioned before. Besides, in parallel, of course, somehow you have to have the knowledge by people, by a system, by internal, external people, however your system is or your concept is looking like. And based on that one, the output will be then maintenance decision, and well, it could be automatic or manually supported. As I said, there's a concept needed, and that is very, very basic, and it's very important. So the concept defines different levels. So you have somebody who's seeing something happen. Let's say you have the operator and he's seeing green, red, or yellow light. So if he sees a red light, he needs to know what to do, because today, in a lot of cases, you're getting a measuring device which gives you data, but most of the time you don't know what to do with that. So in that case, or for that, you need to have a concept. So the operator needs to know what to do. So he gets a red light, and then he needs to know that he has to call this and that telephone number, maybe maintenance, or he needs to just make a printout, or he needs to do some action which needs to be defined, and he should know that he is responsible for that one, and he should know what are the expected decisions from him. So that would be maybe first level. That could be, in our case, some data coming in. The second level, well, some operations people are informed that something is looking red or yellow, and then they maybe get in contact with the third level, which could be then maintenance crew, and they then maybe should decide, okay, as we doing monitoring, we are looking for the things we are seeing and how they're developing over the time, because monitoring is talking about change over the time. So maybe they bring it back then to the first level again, or they just going for further actions like on-site investigations, localization, all these kind of things which can be done on-site. That could be that the fourth level is part of the utility. It could be also that that level is also outsourced. So that is, depends on the concept. And then you have the fifth level. Of course, if you once deciding we need to do some action, of course, then you have to plan the action and to do the action. So you're doing actually maintenance. So the good thing about condition-based maintenance, you can plan that one, you can make it maybe at a scheduled outage, or you can schedule outage at a time which suits best for you. Okay. Then you need, of course, suitable sensors. The sensors should last at least as long as your equipment. In terms of UHF sensors for GIS, of course, it's a piece of metal, so that would last at least as long as your equipment. And here you see some examples for these sensors, so they need to be reliable. You need also a reliable monitoring system, so you don't want to be bothered by false alarms, you don't want to see things you don't need to know. So you want to have the basic information, the important information, and the right information. Monitoring system should be also scalable. Well, you don't want to have for each equipment a different system, because you don't want to maintain maybe 10 different softwares or whatever. So you want to have an overview, or about all your equipment. So just by going into the equipment from a really high level to equipment level to sensor level, and just to integrate all different kind of sensors, different kind of equipment, that should be possible for such a system. That is one example for data integration. You see actually the data concentrator service, so-called, which is actually taking all the signals. You have interfaces defined, and the sensors could come from anywhere. So that is just a question to adapt to interface with different sensors. So one system can handle actually different type of sensors, and so you have one system which giving you information about all your assets. Another example is so-called smart sub. What you see actually is you're going from a very high level to station level to sensor level. So on the left side, we're talking about SF6 monitoring for a GIS, and further on, you can click on your transformer. We're talking about the PD monitoring for GIS or transformers, and we're talking about DGA monitoring. And you're getting all the information from equipment. The data will be processed, and you get all the information in one system. Furthermore, also coming to how we are just analyzing data. Condition-based monitor or condition monitoring is actually joint effort between utilities, between OEMs, between the industry, and also between university researchers, because you need to, or it need to be some logic developed just to assess the data to get out CBM relevant data at the end to help the operation and to help the utilities to operate their equipment. So you don't want to take care about data, you don't want to take care about monitoring equipment, you want to take care about the main equipment. Another example is how this data presentation could look like from the dissolved gas analysis. So far, systems available, which in 96% of the cases are just telling you the true reason for increased gas. Again, we're talking about change, and well, to achieve that one, different kind of methods are used. Of course, you need to take out some data which are disturbing your decision finally, and you need to look on which defects, which faults you want to try to find or prevent. And you need also to think about how we can rate, how I can just show the user sitting in front of the device, how he can access, or how the system can access the health of the equipment. Actually, you can talk about 6-level scale, 10-level scale. You can talk about just giving you recommendations out of it. Well, that need to be defined for each and every kind of data you're looking at. And that is actually how it could look like. That is a visualization of a DGA. You see on the left side the different kind of defects you're looking at, and you see also on the right side the development, and you see the gases content in that oil in this example. So once it gets to red, you know there is something happened, and you know already which kind of defect you're looking at. Okay, just to be able to do that all, you need a lot of data. So you have to manage the data. That is also, if you're talking about a company, if you're talking about utility, if you're talking about university, they have to think about how we can ensure that we are bringing the data in a right shape to be useful for us. So how we can gain out some more out of the data, because we don't want to see data, we want to have an information out of it. So what we can do? Well, and that is talking about moving from data to wisdom, we call it. Well, you get some data, you need to understand the relationships between the data. Out of this, you can maybe understand the patterns, or you should understand the patterns. And understanding the patterns, the next step would be understanding the principles. So once you understand the pattern, then you can, maybe by knowing the data, just simulate what will happen if that data goes in the same direction, as it is going right now. So you get a real understanding about the data. So that is actually what needs to be integrated today in monitoring systems just to support condition-based maintenance. And that is illustrating that maybe even a bit better than the one before. Well, I would say we are here at the moment talking about between knowledge and wisdom. So everybody wants to be at a wisdom side, but we have maybe to do some more to get into the wisdom side to really have the understanding. But to come to that, first of all, we need the data. The second one, out of the data, we have to gain information, and we have to transfer that one to knowledge, and then we will have the wisdom to set up systems which can help us to assess our equipment. And well, condition-based maintenance. Maybe you, as the asset manager, you want to avoid early life failures. You want to capture design and manufacturing flaws, and you want maybe benchmark OEMs, and you want to extend the operational life of your asset. And as a maintenance manager, maybe you want adopt conditions-based maintenance processes. You want to know when you have to do maintenance, because you will maybe have to give a maintenance budget. And you want to improve your safety for your on-site personnel. And as operation manager, of course, you want to have the equipment running. You want to sell energy, in our case. And you want to know how we can overload the assets, especially talking about hotspot temperature. You want to know how far I can go, how much I can sell. And you want to minimize also the time where your equipment is out of service. And you want to manage that one. And talking about the environment, health, and safety manager, well, that's pretty much clear. He wants to improve the safety for on-site personnel. He don't want to have something exploding while people are standing beside. And he wants to limit, of course, the environmental impact. And he wants to improve the compliance to environment in general. So that is actually why condition-based maintenance. We still have some challenges. Today is not many suppliers are able to provide systems which are just covering everything which are presented before. Only a few. Actually, it starts now to talking about these principles, talking about what needs to be done, talking about not only presenting data, also just what does the data mean. And in that it's also not for all kind of measurements. We are really having real-time analytics and dynamic modeling of power systems. So there's still some work to do. And also, if you think about communication infrastructure, sometimes you have maybe stations which are, let's say, somewhere deep in the woods, and you don't not even have a network connection to that place. So, that is also a problem. Still, you will be faced by implementing some kind of condition monitoring, condition-based maintenance. And I would finally close my presentation with some very wise words. Condition monitoring is like an insurance. Everybody agrees it's prudent to have it, but nobody wants to pay for it. Anybody could see the benefits, and somebody always asks why it was not fitted when it's all gone wrong. So thank you very much for your attention, and I'm just looking forward to get questions, to answer questions if you have some. Thanks a lot for your attention. Thanks a lot for taking part on this live webinar.
All right, thank you, Thomas. Like Thomas said, if you do have questions, feel free to type them into the chat window. Next question: if your maintenance schedule is far behind, when is the best time to start CBM?
Well, that depends on also on type of equipment. Mainly, it's so the equipment today it's quite reliable. So the best thing is in that case, well, if you want to start with a condition-based maintenance, then you should it doesn't depend on the maintenance schedule. You need to first think of what you want to do and how you want to do. But to say so and so long time, it's quite difficult. But well, if you are just doing nothing actually, so it means your maintenance schedule is far behind, or you're far behind your schedule. That means then, of course, I would do maybe the maintenance first, time-based maintenance, which is proposed by the supplier. And once you're doing that, I would then try to integrate the right sensors, right measures, right methods to do the measurements. Or what you can do if your maintenance schedule is far behind, and you can just start immediately to do at least some periodic measurements on your equipment, just that you maybe gain first of all some experience with your equipment by yourself, or be supported also by some third parties. So that I would propose, so going for some periodic measurements first, then making a proper let's say maintenance concept, CBM concept, and then you can just implement, and you will not implement it in once because sometimes it's quite expensive, but you can also implement it in just in steps.
Okay.
I hope that answers the question.
Next question is, what have you seen in terms of the additional upfront costs, percentage-wise, to add additional sensors, et cetera, to equipment? Please give an example.
Well, if you're just going to add sensors in that stage where you just buy new equipment, the sensors itself not maybe that expensive. When you add that one in that stage, you can maybe talk about that depends if you're talking about the UHF sensor. Maybe UHF sensor will cost, or equipping a transformer with UHF sensors only, that will cost maybe let's say somewhat $10,000-15,000 something like this, and you can imagine how expensive a transformer is. So well, percentage-wise, that's not that much only for sensors.
Okay, and I think this may be our final question, unless someone gets another one or two in the queue. But would you be able to recommend some algorithms that have been implemented to model the CBM approach?
Well, that depends also on your equipment. You need to look for each and every kind of equipment separately. What I've shown in that presentation were two examples. I just not talked about that clearly because of the time frame, but there is one principle what we're using for PD monitoring in GIS, that is integrating some artificial neural network intelligence into the system, and it's based on let's say on patterns which are recorded over last 24, 20, 23, 25 years, and which is a record now for about I think 2 million data, which are verified, which type of defect you are looking at, and so on. So that is one example, and another example I showed was a DGA, which is also based on some experience and a lot number of data. So you don't have just one single concept for different kind of equipment. You're just having a concept for each, or analysis for each of your equipment type, and that you're bringing them together in one system. The system should be able to be that flexible that you can implement different kind of analyzing tools for different kind of equipment.
Okay. Well, we don't have any more questions, so it looks like we're ending perfectly. Well, actually, we do have one more, which is another good question. Does Qualitrol provide an integrated CBM system?
Yes, I was showing that example. So far, I can maybe just switch back. Just a second. And I just showed it in between. It's so-called Smart SAP, which is actually integrated solution. Well, integrated solutions are never finished, so you just integrate more and more, and then this stage we are. So GIS is integrated like SF6 monitoring, partial discharge monitoring, and so on. And so we're going to integrate more and more into the system. So that is the overall system. Actually, you see the screenshots. They are not just a painting, so it's just an actual screenshot of the software.
Great. Okay, well, that'll be it for today for questions. And again, we want to thank everyone for attending because we really enjoy putting on these webinars for our partners and customers, and look forward to everyone's participation in Q&A. Look for more webinars in the future, and we hope everyone have a great rest of their week. Thank you. Goodbye.